In this video, I will be giving a brief explanation of pointers in the C programming language. Let's begin with an integer variable, which we will call treasure, and we will allocate the value of 10 to this treasure variable. Let's pretend this signifies 10 doubloons, since C strangely has no variable type called doubloons, but perhaps one day. Let's also create a variable that stores integers called myPocket, and let's put in it 0 doubloons, which is unfortunate. However, we will be taking advantage of a powerful tool in the C language to change this. Pointers. Now, all variables are stored in locations in the computer's memory. These locations have addresses. A pointer is a type of variable that stores the address of another variable. Hence, the pointer points to that other variable. I want to create a pointer which points to this treasure variable, kind of like a treasure map. To declare a pointer, we write the type of variable it points to, an asterisk, and then the pointer name. Our pointer will be pointing to an integer variable, since it's going to be pointing to treasure, so we write int, and then we have an asterisk, and then let's call our pointer treasure pointer. How original. Now we need to assign the address of the treasure variable to our new pointer. To get the address of a variable, we use the ampersand operator. The ampersand basically means the address of, so we'll write ampersand treasure. We now have our treasure map. Let's read the map. To print out a pointer, we use the format descriptor %p. So let's write our printf statement. The treasure is at address %p, and we'll include a new line to make it more readable. Put our pointer there. Let's compile and run the code. The file is called Doubloon Thief. The treasure is at this hexadecimal address. This is our map. We can actually use this address to get to the variable stored there. To get to the value stored at the address in the pointer, we use, kind of confusingly, an asterisk again, and then the pointer name. C really loves asterisks. The asterisk in this context is called the dereference operator, and it appears as so. Don't confuse this use of the asterisk with its use when we declare the pointer, like so. When dereferencing, we don't include the type of variable pointed to. Let's try the dereference operator in a printf statement. So printf, the treasure contains %d doubloons, and we'll use our pointer here, and let's dereference it to get to the value underlying the pointer. Let's recompile it, and let's rerun it. Great. We have now retrieved the value stored at the address. Let's also create a pointer for the address of myPocket while we're at it. myPocket. So now we have our treasure map. In fact, let's call this pocket pointer. So now we have our treasure map, and we also have, I suppose, a map to myPocket, which is a bit weird, but just go with it. Pointers provide huge potential, and I now provide a simple example of this. Let's create a function called steal treasure. And we will pass in our boring ordinary variables as arguments. This is one boring ordinary variable. And just to be clear, this is also a boring ordinary variable. I'm not sure if that's a technical term, but let's just use it here. Okay, and now this function will be void. It's not going to return anything. Let's create it down here, and the parameters will also use the same name as the argument variables just for consistency. Now the purpose of this function is to swap the contents of the treasure with myPocket. In fact, let's include a descriptor. Swaps contents of treasure with myPocket. To swap the contents, let's create a temporary variable called temp, and let's put the contents of treasure in there. And then in the treasure variable, let's put the contents of myPocket. And in myPocket, let's put the contents of the temporary variable, what used to be in the treasure. Okay, now remember, C doesn't like surprises, so let's warn it about this function by including its prototype up here. And perhaps we'll get rid of these and create a couple print statements down here so that we can see the contents of treasure and the contents of my pocket after running the function. So the treasure has %d doubloons, treasure, and my pocket has %d doubloons. A new line there just to make it more readable, a new line there. Great. Let's compile it and run it again. So despite the function, the treasure still has 10 doubloons and my pocket still sadly has 0 doubloons. So nothing has changed and I am the worst doubloon thief ever. This is because when we pass the boring ordinary variables into our steal treasure function, we pass them in by value. The steal treasure function basically creates copies of the treasure and my pocket variables. Hence, it cannot modify the original variables passed into it from our main function. However, we can fix this. Instead of passing in our boring ordinary variables, we can pass in their addresses. That is, this exciting, amazing variable and this exciting, amazing variable. And now I think that is a technical term. So instead of passing in these variables, let's pass in pointers to the addresses of these variables. We'll change that to treasure pointer there, change that to treasure pointer, change that to treasure pointer, and put in pocket pointer here, and pocket pointer here. And now the arguments are of type pointer and not type int, so we'll add the asterisk there, and the asterisk there, and there. Great. The steal treasure function will now have a copy of their addresses and we can directly access the piece of memory that the boring ordinary variables occupy. A copy of a treasure map is as good as the original treasure map itself. Let's make the few final edits to our function. We don't want to swap the addresses, we want to swap the values underlying those addresses. So we'll have our treasure pointer here, our treasure pointer here. We need to use the same names as the argument parameters. Our pocket pointer here, our pocket pointer here, and this will have the effect of swapping the addresses, but let's dereference each address so we can get to the value underlying the addresses and swap them. Great. Hopefully we've now swapped the contents of the treasure variable and the myPocket variable using their addresses. Let's recompile. GCC, doubloon thief. Perfect. The treasure now has 0 doubloons and my pocket has 10 doubloons. We're done. Thanks for listening.